Yo guys, yeah man, this is like the last video of us discussing content. The then there's gonna be like two last videos of me solving some questions from an exam paper. So for this section, hopefully I'm not gonna rush it like the previous one. This section we're talking about perpendicular lines and parallel lines. So remember, it's something we did state that parallel gradients must be equal, perpendicular products of the two gradients are equals to 1, right? So they say determine whether the following two lines are parallel. So, for focusing on number A, we see that, you just equation 1 is y equals to minus 2x plus 1. That is equation 1 equation 2, you have y equals to minus 2x plus 3. That's equation 2. So remember, for parallel lines, we don't care about the c, or about your what you call it, your y-intercept. Remember, something I forgot to mention when we're talking about the equations of a line is the y-intercept. These values, the c is a y-intercept. So c is a y, okay, c is a y value. It's a y-intercept. Y-intercept. Let me not complicate it. Intercept. It's a y-intercept, or the y value of the y-intercept, which is y-intercept. So yeah, here the thing is, I have minus 2 from equation 1. I have minus 2 from equation 2. So the gradients are both equal, implying that number A, these two guys, they are parallel to each other. Do you know what I mean? The second one, for B, right? For B, we can say we have 1 equals to x minus 1. For equation 2, we can say we have y equals to minus x plus 3. So here, the equations, the gradient are not equals to each other, right? The gradient of 1 is not equals to, okay, it's equals to 1, which is not equals to minus 1, which is m2. Yeah, something complicated, but something you can just get is that m1 is not equals to m2, so not parallel, right? Not parallel. And then they give something interesting here. They say the line passing through the 2 points, so we're gonna have to calculate that line. Here we have to calculate the gradient and that line that we have here. So maybe let's fix that one first before we calculate the gradient. This side we have, I can rewrite it as y is equals to, I'm gonna have x minus 4. Now this is my line 1, right? This is for C, by the way. And then I have 2 points, changing y over changing x. It's gonna be, if I use my both points, I have minus 3 minus 1. I have minus 4 minus 2. Yeah, everything is negative. So okay, let me see. 4 2 3 1. Cool. Yes. So everything is fine. So that's minus 3 plus 1, that is minus 4 plus 2, that is minus 2 over minus 2, and that is 1. See, and the gradient here is 1. So that means m1 equals to m2 equals to 1, and therefore they are parallel. That was some light, for parallel lines, man, it's not really that, yeah. We have another couple of questions this side for parallels. Yeah, determine the equation of a straight line passing through that passes through this point. right? It passes through this point and it's parallel to this line. So they say it's parallel to this line. Now that line, if I want to write it properly, I have y is equals to I'm gonna have 6x plus 1. This is gonna be wait, I'm gonna divide by 2, man. I'm gonna divide by 2 everywhere. So then in that sense I have 3x plus 1. So I know my gradient now is 3. I use that equation. Remember, y1 minus y2 y1. Then you have your gradient. You have x minus x1, right? To substitute, what's happening? To substitute, it's y minus 6, right, is equals to gradient, which is 3, into x minus 2. That is y plus 6. That is 3x plus 2. That is y equals to 3x plus 6 minus 6, which is 3x. Yeah, 3x. So yeah, man. So that's what's up. Quite easy, nothing complicated. Let's see this one. Determine the equation of a straight line that passes through this point and is parallel. Woohoo! Is parallel to the line with an angle of inclination of 145 degrees, right? Yeah, that is very cool. So we know, let's deal with the angle of inclination thing. M is equals to tan theta, and since tan theta is between 0 and 180, the 145 stays in that range, so we're not gonna do anything here than just substituting the 145, and yeah, then tan 145, what do we get? We get minus 0.7. minus 0.7 is our gradient. Then we're gonna do exactly the same thing. We're gonna use exactly the same formula we used in the previous example. Please guys, please try to make sure you remember this example. No, you remember the formula. Yeah, the formula is very important. Yeah, the formula is very important. Try to remember it, don't forget it. Yeah, so you have y minus 2/5. You have m, which is minus 0.7. You have this is minus 2. So hey guys, I just want to say, someone in my neighborhood is playing some music. I hope the music is not disturbing y'all. Yeah man, sorry. The guy just caught me in the middle of my recordings. But yeah, hey, it is what it is. So you have y minus 2/5 here. That's maybe, let's write it minus 0.7. You have x plus 2, and yeah, then multiplication and transposing. Let's go. We can already transpose that side. So I mean, I don't know what's that. I can't do that number by heart, by my head. So I'm gonna go and jump into my calculator. It's minus 1.4, right? And then I'm gonna have plus 2/5. Let me see, maybe 2/5, if I can write it in as a decimal. It's 0.4, right? Yeah, cool, bro. 0.7x minus 1. Yeah, we're done. We're done. I think I didn't make any mistakes in this one. So yeah, man. Yeah. So I think by that we are done with parallel lines. The next thing we do, let's solve some problems for perpendicular lines. And yeah, let's get started. Cool. Damn. Yeah, I'm so hyped today, man. Okay, calculate whether or not the following lines are perpendicular. So remember, perpendicular lines, the product the product of your two gradients, they have to give you what? -1. So let's go. The first one, we can write it for 1a. You have y is equals to 4x plus 1. And then that's the equation 1. And then the equation 2 is going to be what? We can say that's maybe let me do it step by step. 4y is equals to minus x minus 2, right? Then I divide by 4 all over. I have minus 1 over 4x. Then this is gonna be 1 over 2, right? Then I have my gradients there. I can then say 4, or maybe I can say m1 times m2. Gradient 1 multiplied by gradient 2, that's 4 multiplied by negative 1 over 4, and I get exactly -1, saying that these two, they're what? They are perpendicular, right? Done and dusted. Let's go for B. So for B, 1B, I have for 1B I have y over 3 equals to x. I can just multiply by cross multiply, then I have y is equals to 3x. This is just equation 1. For the equation 2, I have 3y, which will give me minus x minus 9. Yeah, what? No, plus 9. So now I do the dividing. I have 1 over 3x. I'm gonna have plus 3. Then I'm say m1 times m2. That is 3 multiplied by negative 1 over 3. That is what? Bam, -1. So then my lines are what? They are perpendicular as well. So here I'm just focusing on the gradients. I mean, even if I can get this wrong, say maybe I wrote 4 here plus 4. I mean, I don't know how the markers are gonna, handle that issue. But the focus here is on the gradient. So long as you get your gradients correct, you're gonna get the answers correct. So yeah, but of course, try not to make any mistakes. Yeah. Number C. So number C, it's nice. We have 1. Yeah, we have, let me just say minus 2x plus 1 equals to y, or y equals to, yeah, that's what we have. And then I just have to calculate the gradient here. Let me do it here. That's 5 minus 1, and that's -1 minus 2. That's gonna be 5 plus 1 over -3. That's gonna be 6 over -3. That's gonna be -2. So I have -2 here. Is that so? Yeah. So yeah, then -2 multiplied by -2, it's gonna be positive 4, which is not equals to -1. So these two are not perpendicular. Let me check. This is changing y. 5 minus -1, then changing x -1 -2. So yeah, everything is fine for number C, but number C not perpendicular. Number C, they are not perpendicular. Yeah, cool, bro. Damn. We do number 2. So if we do number 2, let's do what? I'm gonna erase this part and then get started. Yebo. Yeah, man. So my neighbors are still making the noise. So yeah, man, sorry for that. Hopefully it doesn't affect the video, bro. Number 2, determine the equation of a straight line that passes through this point and is perpendicular to line number 5. So line number 5, not line number 5. Not line number 5. This line that's 5y minus x, right? So that line, let's talk about it. That line, 5y equals to x, divide by 5 both sides. I have 1 over 5x, right? Yeah, but that's what I have. And if these people, they say, okay, if I want to find the gradient of the second line, the line that passes through 2 and minus 7, I can say m1 multiplied by m2 is equals to minus 1. m1 is 1 over 5 multiplied by m2 is equals to minus 1. And then I can just multiply everything by 5. This 5 is going to cancel this one, so I'm going to have m2, then I'm going to have minus 5. So I know the gradient of the line passing through that is minus 5. Then yeah, then I go to my formula. M2. Yeah, but I've got to say, man, that's some good music they are playing. Yeah, so we have my points are 2 and minus 7. So I have y minus 7. I have minus 5, x minus 2. I have y plus 7. I have minus 5x plus 10. Y equals to minus 5x plus 10 minus 7. That's what? Minus 5x plus 3. Done and dusted. So yeah, man, that's how it's done. Yeah, that's how it's done. So cool. Let's get on to the next one. The next one is the angle of inclination. So erase. So determine the equation of a straight line passing through the point 3 and minus 1, and the perpendicular. Is perpendicular to a line with an angle of inclination of 135 degrees. So I can say my angle of inclination tan theta, so that's tan 135 tan 135, that's minus 1. So then I have say this is m1 multiplied by m2. M2 is equals to minus 1, so minus 1 multiplied by m2 is equals to minus 1. So then what do? I say maybe I divide by minus 1 both sides, minus 1, so m2 is equals to 1. Then after that I'm done. I go back to that formula of mine. Yeah, right. So yeah, I substitute 3 minus 1. If I do substitute, then I have 1 minus y minus y minus 1, gradient which is 1, x minus 3. So then I have y plus 1, x minus 3. To close it up, I have y, x minus 3 minus 1, which is x minus 4. Bang! And then I am done. Yeah, man. That's it. That is it with the parallel and the perpendicular. I mean, more practice, the more you understand these things. And all I can say right now is good luck and all the best. The next video is gonna be about the problem. There are 2 questions I chose, so I'm gonna do 1 question per question, so per video. So yeah, see you there and good luck.